Alright, so I think I'm recording. Let's take a look at solving this equation. It's a proportion, the claim that one fraction equals another, that one ratio equals another. We're solving this by a technique that they refer to generally as to cross product or cross multiplication to cross multiply. So we multiply along this yellow diagonal, and we have 49x plus 5 times the quantity 2x plus 1. Along the purple diagonal, I have 5x plus 4 times 11x plus 7. If we multiply this in the form of a table, (49 times 2, 98). So on the left-hand side, when I'm getting 98x squared, I'm getting 98x squared plus 59x plus 5. On the right-hand side, we got 55x squared, 35x, 44x, and 28. Alright, so let me shrink this up to give myself some more room, if it'll let me. So this is a quadratic equation. I want to get it in standard form of ax squared plus bx plus c is equal to 0. So let's subtract 55x squared from each side, because I'm working towards getting a 0 on the right hand side. The resulting equation, 43x squared plus 59x plus 5 is equal to 79x plus 28, because these terms cancel. Let's subtract 79x from each side. (43x squared minus 20x plus 5 is equal to 28, because these terms cancel. So let's subtract 28 from each side. Alright, so this is a quadratic equation. We can attempt to see, I believe that it does factor, but who wants to take 43 times 23 and look for those products that add up to negative 20? In this case, I would use the quadratic formula if I were doing this. So let's do that. Let's identify A, B, and C. Now the quadratic formula, let's recall what it is. It's a solution to the equation ax squared plus bx plus c equals 0. The denominator is 2 times this a, this coefficient. The numerator has two terms. The first term is the opposite of this middle coefficient, the opposite of b. That since there's two solutions, but they're so symmetrical, they write a plus or a minus sign here. It's just shorthand notation for actually, like I say, two solutions. Then we have this radical, and underneath this radical is what they refer to as the discriminant, and it is b squared, b times b, minus the product of 4 times a times c. So let's go ahead and replace our numbers with the a, b, and c we have in the formula. The opposite of b, the opposite of negative 20 is positive 20. We're then going to square our negative 20. That'll be 400. Then 4 times a times c, and I don't know what that is. I'll use a calculator here in a minute to get it. In the denominator, if we take 2 times a, 2 times 43 is 86. So I've got 20 plus or minus the square root. Let's figure out what this number is. The negative 20 squared, like I say, I know that's 400, and we're going to subtract that from 40 times 43 times the negative 23. 4356. Now, I'm not good enough at mental arithmetic to look at that and to recognize that that's a perfect square, but I suspect it is, just because I don't think they would give us, let's check and see. Yeah, 66. So we have two solutions. One of them says to take 20 minus 66 and divide it by 86, and the other solution says to take 20 and add 66 and divide that by 86. That one's easy to do because 20 plus 66 is 86, and 86 divided by 86 is 1. Now over here, what do we have? I don't need a calculator for that. I do need some extra room. So 20 minus 66 is a negative number, negative 46. And both of those are even numbers. So I've got negative 23 times 2 is a negative 46, and 43 times 2, and 2 divided by 2 is 1. So I believe that our solutions are 1 and negative 23 over 43. Let's go check that against our key. Yeah, here it is, 18. 1 or negative 23 over 43, which is what we got. Yeah, all right. So let's move on. Let's take the cross product, make this a little bit bigger. If we have x plus 7 times x plus 1 and x plus 3 times 2x minus 1. Using a table to multiply that would be probably best for most. But you should get 8x squared plus 8x plus 7 over here, 2x squared plus 5x minus 3. So let's get this in standard form. I'm going to subtract 1x squared from each side. I'm going to subtract 8x from each side. I'm going to subtract 7 from each side. And this we can factor with our x method. We know that if you have two numbers that multiply together to get you negative 10, but add together to get you a negative 3, when the leading coefficient is 1, you can always take this x minus 5 and x plus 2 from the x plus 2. So we have a theorem that's a zero product theorem. If two numbers multiply together give you 0, then at least one of these numbers has to be 0. So it might be the number x minus 5 and add 5 to each side. It might be the number x plus 2, subtract 2 from each side. Our restrictions were -3 because that would have given you division by 0, and -7. So since neither one of these are those, neither one of these are extraneous, and that's our solution. This one's a little more difficult for some to see the restrictions. 3x minus 4, we can't allow it to be 0, which means that we can't allow x to be 4 divided by 3 because that gives you a 0 in the denominator. 2x plus 4 is equal to 0. If x were allowed to be -2, then 2x plus 4 would be 0. We can't allow that to happen. We can't have division by 0. So they want us to state these restrictions now to be aware of them. So if you get your answers from the cross product could result in one of these values in which you'd have to throw it out. Doesn't happen often, but it happens often enough that you need to be aware of it. Alright, so we've got 2x plus 4, x plus 2, 3x minus 4, and 2x plus 1. If you use a table to multiply these together, what you should get is 2x squared plus 8x plus 8, and over here 6x squared minus 5x minus 4. If we get this in standard form where one side is 0 and the other is ax squared plus bx plus c, if I take 2x squared away from each side, if I take 8x away from each side, if I take 8 away from each side, now if I use my x method, and this is where the x method is definitely an advantage because my leading coefficient is not 1 and it's not prime. So it's a little bit harder to do. That's why this method is a nice method. So two numbers that multiply together to give us -48, but add together to give us a -13. 16 times 3 is 48, right? 16 times 3. Yeah. All right. So if we make that 16 negative, then -16 times a +3 is -48. If you add those together, you get -13. Now in the body of the table, we put the first term and the last term along one diagonal, and the numbers from our x along the other diagonal. If I look horizontally, these share a common factor of 3. If I look vertically, these numbers share a common factor of -4, and +3 times -4 is -12. If I look horizontally here, both of these numbers are divisible by 4x. And if I look vertically here, they're both divisible by x. And 4x times x is 4x squared. And -4 times 4x is -16x. 3 times x is 3x. So we have found the correct factorization. So again, if these two numbers multiply to give us 0, then at least one of the factors is 0. So it has to be true that either 4x plus 3 is equal to 0, or that x minus 4 is equal to 0. This results in x being equal to negative 3/4, which is not one of our restrictions. And over here, if we add 4 to each side. So both of these solutions are fine. Either one of them are restricted. Alright, so let's move on. Actually, I'm going to have to do the rest of these problems in another video. So I hope this helps, and I'll talk to you later.